So we're going to get into chapter 10. And chapter 10, it sort of takes a turn. It comes back to something we're talking about way earlier this semester, about correlation between two variables and how that relates to causation. So there was I don't know how many of you guys, actually I think I did know how many of you guys like the website, or go to the website, Reddit. But they're a really good source for turnout. It's really Wikipedia. How many of your teachers have told you Wikipedia is bad? Anybody? Of course, they are full of shit. Wikipedia is an awesome place to start. Right? So I don't understand the huge blowback against Wikipedia. It doesn't make a damn bit of sense. You go down to the sources for the articles you read, and then you go there. And those are, normally out to journals or something peer-reviewed or something you can totally trust. So not a damn thing wrong with Wikipedia itself, as long as you use it correctly. That's basically the whole internet right there, right? If you use it correctly, you're fine. If you don't,
you're screwed.
Yeah, in so many different ways, yeah.
So is it good to be aware that Wikipedia is not always right, like when they give out information?
It's good to be aware that there is a probability that Wikipedia articles could be wrong. But the safeguards they put in place are pretty damn good, especially for the more important articles, right? But I want to show you something, a couple things, real quick. We talked about something silly, like somebody going out to a basketball game, and they say, man, basketball makes people tall. That's just stupid. You're like, you're not a smart person writing that down, right? I mean, that would be silly. But that's sort of the level, that one we know. We know that that's crazy. In reality, people are tall or more likely to play basketball, right? I mean, I played basketball. Not very well, but I played. I liked it. I had a good fadeaway shot. That's the only shot I could possibly hope against the other people. But we know that that's not right. But there's situations in life where we don't know what the right answer is. I was listening to, I know everybody listens to NPR, and they had a thing about wheat growing cultures versus rice growing cultures, and how the wheat growing cultures are more individualistic, and the rice growing cultures are more group oriented. You kind of with me? And this is actually, if you think about it, kind of makes sense. It actually seems to be true. And their argument was, if you evolved and you grew rice, you had to work together. To actually grow rice and to harvest rice is a huge group activity. But if you're growing wheat, not necessarily. You don't have to work together as much. It's not as crazy to try to do that. So it's really interesting. But the question was, well, are you sure that caused them to become that way? Or maybe they were that way and they grew that kind of thing based on how they were. No, let's try rice. No, I hate all you people. I'm going to grow some wheat. Right? You guys, are you all? I mean, to me, that's interesting. But I never know if you're going to be at least even vaguely interested. That's kind of cool. And the way you do this, and again, this is going back to Mythbusters. You guys watch? Have they had a new show in a while? Have they missed it? Damn. That's why you guys are all just staring at me like, what the hell are you doing? But you always want to try to control for certain variables. So what do I mean by that? When they had the wheat and the rice thing, somebody brought it up. Well, maybe it was the other way around. Maybe they just grew rice because they were cooperative. But what they did was they went to locations anywhere that they could have grown rice, they did. And what they thought was, if it's maybe true that they would have grown wheat instead, then somewhere where rice could have grown, there should have been people not growing rice. They should have been growing wheat if their culture just happened to be not cooperative enough. Does that sort of make sense? So you're trying to control for that variable in a way. So, what we're going to do... Oh, I'll show you one more thing. So you can find it real quick.
So you have to switch views first?
Don't worry, I got to find it first. Here we go. There it is. This is good. All right. Sorry. I'll make that less of an inside joke. Go. So I don't know if you guys can see that. So the number of people who drown by falling into a swimming pool correlates with the number of films Nicolas Cage, I love how you spelled Nicolas Cage appeared in. You can't really see, you can barely see this other line here. So they look at each year, the number of films, and it looks like if you follow it, now today we'll actually be doing more than just graphing. I mean, graphing kind of, if you graph and you see them following each other, that's sort of a visual, yeah, it looks like they correlate. I can see it. But today we're actually going to be doing the hard math too, mostly in the calculator. But it's really, that's kind of eerie. But the thing is, this really hits home that just because you see a correlation between two things does not mean that they actually, either one causes the other one at all. Is there any reason, if I fall into a swimming pool, if I know somebody drowned, I'm not going to go tell Nick Cage, hey, you should go make some more films, because, you know, it would make me feel better about my friend that fell in the swimming pool. No, there's no reason that one should affect the other one at all. You with me? They just happen to be this way. So the beautiful thing about statistics is it'll show you things, but we as the humans have to step back and say, does that make sense? If it makes sense, I need to go look at it closer. This one, I'm not going to do any follow-up studies. Right? I mean, they just made the picture just to show how you have to be careful with correlation. There was more than just this one. I don't know where. But there we go. So the divorce rate in Maine. Go away. Stop it, Firefox. Divorce rate in Maine versus the per capita consumption of margarine. Oh my God. What we'll learn today is the closer this number is to 1 or -1, the tighter the fit. The more closely they align with each other. And you can see they line up really damn close, don't they? So just because more people eat margarine, suddenly people in Maine go, I feel a disturbance. I don't like you anymore. Right? I mean, so I don't, this is not me, obviously, trying to get you to not believe in correlation at all. A correlation merely means that two things vary somehow directly. If one changes, so does the other one. So that could mean that one does cause the other one. So if I look at the number of hours a student studies versus the grade they make, you can think that overall there should be some kind of connection there, right? There will be people that go against it. There are people that do not need to study. They get everything they need in class, and then they just fill it back out on the test, and they're fine, right? And some of you guys are like, I am not that person. And then there's people that study their ass off and still make, less than they want to, just to be politically correct. You guys kind of with me? There's always going to be people against that, but you know that there should be some relationship between the amount of homework you do versus how you do or studying you do versus the grade you make, right? And I always do this. I always look at the people who actually got the most on-time homework that I looked at and it was good. I kind of, people that turn it in on the day of the test, I give them like a point. But people that turn it in before and I graded it and it was good, I give them 2 points. And I kind of do this point thing. And I versus that against their grade. And I see the correlation. And it's always really good. It's a little too early for me to tell you exactly what it is because we don't know what good means yet. But it's always a good correlation. So math is just telling me, oh yeah, those two numbers, they kind of go together. If one goes up a little bit, so does the other one. That would be a positive correlation. You guys with me? So the math just says, oh yeah, they do that. I've got to step back and say, is it a margarine versus divorce rate problem? Where it's just kind of like coincidence? Or is there really something that's tying these things together? And of course, the more homework you do, the better you should do on the test. That kind of makes sense. It makes sense that would be why. How are we doing so far? So I have a silly example, and then a not so silly example. Someday. There it is. All right. Oh, let me actually give you some copies of this, so you don't have to just rely on this. Thank you. All right. So, my first example is, I don't know if any of you have lived this. This is not me recommending you do this as an experiment. I just want to make sure you understand. If you do it, it's not because I said to. Some of you guys might have lived this. So the number of beers you had the night before versus a grade you make in your... Can you imagine having a 7 a.m. class? I've taught that early before, and I don't know if you can call it teaching. I
call it easy way to fail.
I was standing in front of a room, or at least I was dreaming I was. So the number of beers you make the number of beers you had the night before versus the grade you make on a test, that's really early in the morning. So you'd expect... Now, which one of these graphs would you say is a stronger relationship, a stronger correlation?
The second one?
Yeah, because they're really tight to a line. You can imagine a line going right through them, and most of the dots would be at least close to that line. You with me? So, the same way that we created a formula for standard deviation that gave me an idea of how spread out my data was, I want something very similar, except now I want it in 2 dimensions. Now, some of you guys are like, oh shit, are we going to be doing some weird-ass calculations in 2D? And no, don't worry about it. I'm going to tell you the idea behind what we do. And then most of it will be in the calculator, because the formulas are just so complex, they don't really help us gain anything. But I want to point a few things out about it. So the tighter the points are to a line, the stronger the correlation. Now, we're going to be talking about linear correlation today. A while back, you did a thing about the temperature versus the amount of energy used, and it was parabolic. Right? Of course, if it's really cold or really hot, you're going to be using more energy for your AC or heat. In the middle, you're not going to use a lot of energy. You guys with me? So that would be parabolic correlation. That would be what's called quadratic. Remember the quadratic formula? That would be quadratic correlation. We're not doing that. We're going to base ours on strictly linear correlation. But there's all kinds of, you can do cubic correlation, quintic, logarithmic. You can do all kinds of correlation. We're just going to do linear. So that would be the stronger fit. But which one is more realistic? Yeah, this guy is more realistic. Who's this person? Well, be more specific.
Tipsy.
Come on now.
Lightweight.
Drinks less.
So he's the guy, or the girl, that did not have a lot of beers, but did not do very well on the test, right? So maybe that's the person that no matter how many beers they had, they're not going to do well on the test. So maybe they should have just went in and had more beer. I don't know. Let me see. Oh, I got a laser. Who's this guy here?
Drank a lot.
High on test. That's one like every damn test, man. I'm living this. This is a person that could drink a lot, so maybe they have a high tolerance, and they know a lot of shit, so they still did really well, right? So in real life, it's not likely going to line up like this, unless you have something that I consider kind of foolish, which is have a little fish, and then wait some time and measure how long it gets. Of course, that's going to be pretty straight line up to a point. You with me? So like we were talking about the other day, the growth of somebody, you'd hope to God to be straight line for a while, but then somewhere, please level off so we don't have the 50-foot tall woman rampaging around town. All right, so this is the one that's more real life. Can you still see kind of like a what's called a line of best fit? Here the line is straight through there, right? There's the line straight through. Can you still see sort of a line here? Yeah. Especially if you kind of put your thumbs over the outliers. Yeah. Especially then you can see that like it goes like this, right? The outliers certainly make it kind of weird. Then it doesn't seem to have any correlation. You with me? So if the dots were all over the place. So let me make a couple things really formalized here. Let me get a writing instrument. Come here. All right. Don't fall down. So the more spread out all the dots are, the less lined up they are. The closer our score, we're going to call it R. The closer R is to 0. The more lined up they are, now this one would be R equal to -1, or close to -1. Because it's a negative correlation. You with me? R equals 1 would be perfect positive. So if I had dots that lined up perfectly, so a line would go straight through them, this would be R equals +1. If I had a lot like this, that would be R equal -1. Now what about if I had something like this?
0.
Yeah, it would be no correlation. Because as x changes, maybe x is how high I jump. And y is the height of this building. So if I jump really high, how does the building react? Hopefully not at all, or people outside are really freaking out right now. Right? So the height of the building is set. As I change my x, y doesn't care. So obviously that would be 0 correlation. They don't correlate at all. When one changes, the other one doesn't care. So you got to be real careful. Just because it makes a straight line does not mean there's a correlation. It's got to be some kind of actual change. So this one, as x gets bigger, so does y. That would be positive correlation. Perfect positive because it lines up perfectly. Same thing for that, just negative. How are we doing so far? Yes, sir.
So are we just dealing with like 0 and 1?
Well, you can have anything in the middle. So that this example I showed you a minute ago. Now this will make a little more sense. Come to life. 0.99255. See that? So that's really close to perfect. Well, actually, they should have said negative. It's too bad for us because it's a negative correlation. Or wait a minute. Let me be careful. The way they've drawn this is different from the way I'm drawing this. They didn't plot the points themselves. The actual this. So this would be, I would plot the point 4.9 and 5. And then I would plot the point, whatever this is, 4.7 and 4.8 roughly. All right, so they didn't plot one versus the other one. They plotted both of them versus time. So it's not really going to be the same as what I'm going to do here. So this would be positive correlation because as one goes down, so does the other one. So the two negatives would cancel. Are you guys kind of with me? It's exactly like slope, really. Same kind of idea of up is positive, down is negative, and so forth. Okay. All right. Okay, so that's not too bad. And then just one more example real quick. So this one's stronger. Correlation. So here's the one I was talking about earlier, the hours you study versus the grade you make. So again, the one that's stronger would be, yeah, this dude is lined up a little bit better, right? There seems to be a little curve to it, but it's still a pretty strong linear I can't move my hand that way for some reason. And then this guy is weaker, but he's more true to life. Because again, who would this person be?
Barely studied.
Barely studied a good comment.
Yeah, barely studied, but they got a good grade. So they're the people that kind of absorb it automatically. They're the people that you wish would share with you how they do that, right? And then who's this person? Studied their ass off and still
Scored low.
made the second lowest grade. Shit, sorry. These things happen. Normally that's because this person does not know what studying really is, right? They say, I stared at the page for 8 hours. Well, that's your problem. Yeah.
So is it like without the 2 points? Is it going to go like up a little bit?
Say again?
Is it going to go up without the 2 outliers, like the line?
Oh yeah, no, I think even with the outliers in there, I think that's definitely, you can see the line. Could you see the line going like this? Yes, sir.
So why was it equal or about 0 for the top one? Because you said the first
It's close to
one was-
0, I'd say. I'd
Yeah.
say it's close to 0.
There was still kind of a line there.
There's still kind of a line, I could see it. But it's almost like, I could almost make a case for it going like this. There's just fewer, how do I say this? I would bet, in fact, on the back of this page, I have data that I've made to correlate with that. I just used that word, sorry. Data that I made that kind of goes along with those dots. So we're going to actually plug them in the calculator and see what R really is. But my guess would be it's semi-close to 0, but it's going to be some kind of a negative anyway. So really weak, I would call it a weak negative correlation. Because you're right, I can still see a line sort of there. Good, good, good. I like it. All right. So we call this thing that we're using, this variable that actually tells us how strong the relationship is, we call it the correlation coefficient. Or the Pearson product. I think this book calls it the correlation coefficient. My instructor's name was actually Pearson, but he had no relation to the actual Pearson. I'm sure you wanted to know. So we use a symbol R for this, and I often think of it as almost a 2D standard deviation. But it's not really, because it can be negative. But that just tells you the direction that things are going in, right? Blah, blah, blah. Values between -1 and 1. We talked about that already. Now, here's the cool thing. So we can find the strength of a correlation. If it's 1, it's really, Dan, it's as strong as it could possibly be positive. They perfectly line up. We can find the strength of it, but we can also find the line of best fit. So if I have a bunch of data, actually, let me just draw on my picture. Stay. So I have a line of data. If I have a lot of data, I can plug that data in, and it'll spit out to me the equation of the line of best fit. So maybe it'd be something like that. You can't really see that. So maybe the line of best fit would be like this. And what we call that, the process we use to do that, we're not actually going to do it. We're going to let the calculator do it for us. It's called the least squares. So when I plot that line, what am I trying to do when I try to draw that line in the right place? What does that line really represent? Why would it be wrong for me to come here and say, I think it's this? I think that's the line of best fit. Why is that so wrong?
Doesn't match the dots.
It's going in the same direction, right?
Yeah, but it doesn't overlap.
All right, good. So, and this is why I call it the sum of the least squares fit. It's because I take how far away each point is from the line, and I want to put the line so it makes all those distances squared the smallest they can be. So what this line is trying to do is trying to be a graphical average of all the points. Does that make sense? So that line is sort of like X bar in a way. It's actually the average of all the points. So this doesn't make any sense. It's too low. That would be like everybody's in their 30s and I think the average age is 8. Okay, something went wrong, right? So that's way too low. It should be in the middle here somehow. It should be the distance away to all the points should be the lowest possible that they could be. It's got to be closest to all the points at once. Yes, sir?
So how do we get the average of all the points?
Oh, yeah. So that's where we get the weirdest looking equation we've had so far. So let me show you this equation real quick. This is the one chapter I do not mind at all just using the calculator to do the work. And I'll show you why. This is page 506. Okay. That is the formula for R, for the correlation coefficient. A couple things I want to point out. I don't know if you guys will remember this, but these two look very familiar. They look sort of like part of the standard deviation formula for X and the standard deviation formula for Y. So it kind of makes sense that those two standard deviations should show up in this formula because they are tied. The standard deviation kind of makes sense. This is almost like its own standard deviation. So it's not surprising to see standard deviation kind of stuff showing up. Also, I want something about the mixture of X and Y. How do they work together? So we see these cross terms, these sum of X, Y cross terms in here. But if I were to make you do this for a problem, it truly would just be busy work. Whereas I don't care if you disagree with me, you think everything else I've done this semester is busy work. You're wrong. It wasn't. It was actually trying to show you where this stuff comes from. This is just insane. I'm not going to make you add up the y squared and add up the x's and all this kind of crap. No. What's more important is that you understand how to interpret what the calculator spits out at you. So if it spits out at you r equals 0.2, you should be able to say that's weak, positive correlation. It's not a very good fit. You guys kind of with me? Because it's closer to 0 than it is to 1. Okay? So a question that might be crossing somebody's mind right now is, well, what's weak and what's strong and what's medium strength, and are we going to get into that spectrum of stuff? No. But there's a cutoff point. And I'll show you the table that tells you the cutoff point. So we're not going to use this formula. So I just want to show it to you. What we're going to do is we're going to use the calculator. And if you don't have your calculator Bible with you, I've got the little part, hello, on the back. That's the part from the calculator Bible that deals with this. So we're going to do this one together, and then I'm going to want you to do the other one by yourself. So if you got this, you got that to reference, right, how to do this. But here, I'll show you how to do this. Okay, so the first step is to put it in LS1, LS2. Let's just take a minute and do that. This will be exciting.
This and L1 is about.
So we're doing the Beers versus grade problem. Good. Yes, sir.
So we don't put them in order, like ascending order?
Well, do you think you would ever want to sort both of those
No.
lists? Why not?
Because
They go together. It's a lot like that section 9.4. We had somebody before they did a weight loss thing, somebody after. You wouldn't want to sort them around so I get somebody else's weight. That would be, maybe that would be good. I don't know. So you definitely never, ever sort this, or else you're just going to tell me, everything in the world is correlated, Jeff. I just keep getting a straight line. Of course you are. You're forcing them to both go the same direction. You don't want to sort this ever. Let's do 4.5. All right, how you guys doing? You there? Okay. So the first thing I want to do is graph the dots to see if I captured what was on the handout decently well. That was my attempt. was to make up points that kind of captured that picture. So here's how we graph this. If you've got your own calculator, and you don't change what we're doing, if you do it right now, it'll be set and ready for you come quiz or test time, right? If you don't have your own calculator, that's too damn bad. You'll have to, you can see me before the test to make sure everything's in the right place. So where you want to go is see right above y equals where it says stat plot.
Yep.
It's second y equals to get into stat plot. So it should look like that. All right. If any of these are on, go ahead and hit number 4. Enter. Let's just make sure everybody goes in having everything turned off. And if you're in some other class, some algebra class or some pre-calculus or whatever, and your calculator says error, dim, mismatch, and all this weird shit, normally it's the stat plots are on. Go turn them all off. And then you won't get that error. But if you go back in, second, y equals, it should be, everything's turned off. Just go to number 1, get in there and hit number 1 or hit enter. Everybody with me? Yes, sir.
I just want to have plots on.
Oh yeah, number 5 is, it turns all the plots on. Don't worry, you only got 3 plots, so they're all off for you. Everybody on the screen? Okay. Turn this bad boy on, say enter when you're on top of on. We want to do a scatter plot. Remember scatter plots way back from chapter 2? Notice there's also histograms and box and whisker plots in there. X list is L1. L1, we put the X stuff in L1, we put the Y stuff in L2. So you can change those if you need to. And then you get to pick if you're a square, are you positive, are you a speck of dust in the universe? Which one do you feel like today? I'm pretty much always a square. I teach math. What can I do? All right, how we doing? Now, if you hit graph right now, it's going to be sort of anticlimactic. It's like, there's even stuff in there. Ooh, look at that. It's left over from normal distribution. Like, right? I think very few of you guys are going to see any of your points. So here's the key. If you have anything in y equals, go to y equals and clear that stuff out. Clear. Get it all gone. So there's no overlapping lines and all this weird shit. Whenever you put new data in, you must do the following thing. Go to Zoom, and then you tell me which one. You might have to scroll down.
Zoom stat.
Yeah, it's crazy. Zoom stat, number 9, I think. Everybody should be there. Let me know if you're not. Go to Zoom 9. That'll find your data for you. Very good. You got that selected. So now go to Zoom. I got this. Zoom stat. There you go.
I don't see that one.
It doesn't show it.
Oh, okay.
Now compare that to this guy. It's not too bad. I try to capture this guy, and I did. I got the outliers and stuff. Not too bad.
Doesn't show the line though.
Say again?
Doesn't show a line though.
We haven't told it to yet.
Oh.
Right. I know it costs a lot of money, but there's only so much this thing will do for you without being told. All right, so it doesn't know you want a line of best fit. All it knows you want is a scatter plot. That's all we told it. Yes, ma'am. Oh, man.
And that has back on my
Go to stat line. Second. Yeah. Go ahead and back in. And when you're top one, hit enter. Now it's turned on. So now go to Zoom 9. And this guy's a little freaky. I think he went in there wrong. I bet somebody's got a grade like 11 there.
Oh,
Okay. Now, just like anything, you hit one thing wrong and the whole thing goes to shit. So normally, if you're taking a test or something, it'll just sit there and stare at it, come up and show me, and I can find something real quick what's going wrong. You with me? On the day of the test, the day of the final, you're going to be doing all this stuff in your calculator and then coming up to my desk and showing me everything I'm about to tell you. So one thing I need to see is this, and then the next thing I need to see is the line of best fit on top of it. So we got to figure out how the hell to do that. Okay, how are we doing so far? So far we have barely done anything. You're all like, I'm not excited. You just gave me the same damn picture you already had in your stupid handout. I'm like, all right. Rough room. Now go to stat. Calc. Now which one of these looks like it's going to be useful?
Linear.
2-var stats would be really useful if I was making you do that formula I showed you for R. Because it'll do sum of x, sum of y, sum of xy. All the like mixture between the two variables. I'm not going to make you do that.
Linear.
Yeah, number 4.
Slope.
Notice how, I'll get there in a second. Notice how there's also quadratic, cubic, quartic. We only went linear, but if you go further down,
Linear.
yeah, natural log, exponential. And then for some damn reason, let me see if they did. Do they still do it? Maybe not. They used to have oh, there it is, number 8. I missed the total. Look at number 8. What's the only difference between number 8 and number 4?
AX plus BM plus.
Yeah, A in number 4, A is the slope. I love it. And number 8, B is the slope. Why? I don't know. I can't answer that. Just in case you don't want A to be slope, you can use number 8. We're pretty much going to always use number 4. So we hit enter on number 4, or just hit the number 4. It defaults to list 1, list 2. So if you put your data in list 3, list 4, you got to put L3, comma L4 here. So we can just hit enter. Let's see what we get. All right, I just get that, which is actually a decent amount of stuff. What looks right here? I mean, we knew that the correlation should be negative. And what kind of verifies that? The slope is negative. So the slope of my line of best fit is negative. B, of course, the 89.8, that's the y-intercept, right? You guys are all like, man, what? Lines? Yes?
I didn't get the exact because they gave me the value.
Don't worry, I got you. Anybody else get more stuff?
No.
Some of you guys got more stuff. Some of you guys got exactly the stuff we want. You got R squared and R. I didn't get R squared, that sucks. So, you ready? If you did not get anything else, if you only got what I got, you're going to do the following. If you have your own calculator, you never have to do this again. If you don't have your own calculator, you're going to help me turn the calculator you have on. Here we go. Hit second, 0. Okay, you guys with me? This is the catalog. This actually lists alphabetically every damn thing this calculator does. It's kind of crazy. The very first thing, absolute value. That's kind of nice. You can search alphabetically. You want to go to the D section. So you want to hit this button here, the one that's got matrix on top. See the little green D? The X to the negative 1, the reciprocate button right there. Hit that button for D. You guys with me? Okay, I'll take that as it's going okay. So day of week. That's freaky. I've used that exactly never. Not sure actually even what it does. So scroll down until you get to diagnostic on. You're not allowed to ask me what this is all about because I don't care. It's just going to turn on. It actually turns on a few things. It doesn't mess a damn thing up. Just for some reason you can turn certain things off. And one thing it turns on is the R. It actually allows R to show up. You guys kind of with me? So you only have to do this once. So hit diagnostic on, hit enter. And then you have to actually hit enter one more time to say, yes, do that, please. Thank you. So like when you're on the phone, did you mean to hit 1? Yes, I did. Hit 1 again if you meant to hit 1. Yes, I did. You guys don't have that happen? All right. Or is that just evidence why I'm a teacher? So now that was kind of like, whoa. But if you go back, if you go stat, calc, number 4, enter, now R should show up. And just like I predicted, and of course, I know the freaking number already, why wouldn't my prediction be right? But R is negative, closer to 0, right? So negative 0.33, that's really weak negative. How are we doing so far? Yes, sir.
How about the graph? If it's vertical, it would still be r equals 0. If it's
Beautiful. Exactly, because then as y changes, x doesn't care. So they don't correlate. Good. Okay. R squared actually, it's sort of like sigma squared versus sigma, variance versus standard deviation. There is a purpose for having the square, but we're not there yet to understand what it really means. Just to give you a real quick, well, I don't know. What this means, very roughly, is that the correlation in the grades, the change in grades, 11% of it is explained by beer consumption. That's why it's such a weak relationship. It's a very weak relationship, you with me? But 11% of the variance in the grades is explained by beer consumption. When I'm doing a correlation study, I'm trying to find what's the variable that affects it the most. I want r squared to be really high. So if r is 1, r squared to be 1, that would be 100% they're lockstep. You kind of with me? Sort of, not really. So what's more important right now is just the r is negative, which goes along with the negative slope. Good, good, good. So write this down. Let's write this down. What's the equation of the line of best fit is y equals negative 2.54x plus 89.8. Right, just round it a little bit. You guys with me? So that's what I need when I ask you for the line of best fit. Put that equation down there. Now if we go to y equals, here's where things get really neat. At least for me. We put into y equals, hit your y equals button. Put in there negative 2.54 x. Don't forget your x. Plus 89.8. And then when you hit graph, it'll draw that in. That looks pretty good.
Where's the X?
Oh, the X button is right below, right next to your alpha button. There's the all-purpose variable button. X, T, theta, N. Yes, sir.
So that graph is the same graph as this one?
Roughly. Yeah, I made that and then I tried to make points that kind of captured that. So I don't think I got too far off. It's not real data, so who cares? Like I said, I don't think the school would like it if I did that as an actual study. All right, how are we doing so far? That wasn't very impressive because it's really weak correlation, but it is negative like we thought. If we took out those two outliers, what are those two outliers? Well, if you hit trace, you can actually trace it and go around. So that one right there is the 0.768, the one that barely drank anything, but still made a bad grade. And the other one, let's see. There, 4.591. So stay with me for a second. If we go in here into the list and we take out 0.768, and we take out, what was it, 4.591. With me? And then we redo this. We use stat calc number 4. Look what R does. So what happens? Taking those two outliers out, what happened?
It increases.
You got a stronger correlation.
You've got a much stronger correlation because if you thumb over it, it's a very strong, you can tell exactly where that line should be. And our line now has got a much steeper slope. It's got to kind of like align itself to be a lot more close to those middle points. You with me? So very often, outliers might be incorrect data collection. Like somebody said, "How tall are you, sir?" And they said 7 foot, and they put down 7 inches. That's going to be an outlier, right? So sometimes you could pull those out, and you're fine. Those are just obvious data collection errors. Your correlation gets much better. It's more true. But I could just take those out and say, "There's my data." That's lying. because those were true data points. They point to why it's not a perfect correlation. There's always going to be people that, no matter how drunk you are, you're going to do well on the test. And no matter how sober some other people are, they're going to suck. So that's what it's really trying to tell me. It's not always true. So you guys, if you haven't done this already, go ahead and try to do that whole thing we just did with the set of data about studying versus grades. And call me over if you need some help.
So these, all of these are outlines. This is an outline, or which ones are not?
Pretty much all the time.
Yep.
So do it for this data here.
So we want to get rid of that outline. We have a stronger relationship.
Because those are the ones that are kind of like pulling that line out of.
So these three are outliers.
So once we took those away, you got a much steeper slope, so now I can follow the chunk in the middle.
How about this one? This one left.
It's not really an outlier because it does follow this pattern here. Right?
Oh.
Yeah, but you're right. Sometimes you can't tell which ones are the outliers, and you only want to take them out if they're truly incorrect data. So what I just did, by taking them out, was actually illegal. If I did that in real life, they should bar me from writing journals, articles, because I can't just take data out. But if somebody said somebody was 7 inches tall, I feel pretty good about taking that out. That was obviously wrong.